Welcome to Shiba Code. In this video, we will solve a Leetcode problem in under 3 minutes. The problem describes a car that starts at position 0 and speed 1 on an infinite number line. The car moves based on a sequence of instructions: A, accelerate, and R, reverse. When the instruction A is given, the car's position increases by its current speed and its speed is multiplied by 2. When the instruction R is given and the car's speed is positive, the speed is set to -1. Otherwise, it is set to 1. The goal is to find the shortest sequence of instructions to reach a target position. To solve this problem, we will use the breadth-first search (BFS) algorithm. First, we will define the car state as a pair of position and speed. We will keep track of the current car states that have been reached in the same number of steps and update them to transition to their possible next car states in each step. For each car state in the current states, we have 2 options to transit it to the next state, either accelerating or reversing. If we have already visited the next state previously, we can ignore it and don't need to keep it in the current car states. We will continue updating the current car states until one of them reaches the goal position. Once achieved, we will return the number of steps necessary to reach the goal. Let's see how the algorithm updates the car states. We start with the car state of position 0 and speed 1. The first thing we do is update the current car state with the 2 options available to us: accelerating and reversing. Since we haven't visited the new 2 states, we will keep them in the current car states. We then update each car state in the current states again with the 2 options. However, in the next step, we can see that one of the new states is the initial car state which we've visited before. Therefore, we will remove it from the current car states. We repeat this process, updating the current car states with the 2 options available to us and checking if they have been previously visited until one of the current car states has reached the goal. Let's take a look at a C++ implementation. We start by initializing a queue which stores the current car states and a map which stores visited states. We also store the initial state in the queue and the map and initialize the number of steps as 0. Then, for each state in the current state, the code checks if the goal has been reached, and if it has, it returns the number of steps required. If not, it continues to update the state with the 2 options, accelerating and reversing. First, by accelerating, we increment the state's position with speed and doubles the speed. If the next state is within the target range and has not been visited before, it is added to the queue and marked as visited. Then, by reversing, we change the direction of the speed to either -1 or +1, and again checks if the next state is within the target range and has not been visited before, adding it to the queue if it has not. Once all the current states have been updated, the number of steps required to reach them is incremented. This process continues until the goal is reached. I hope you found the solution we presented helpful and easy to understand. If you have any questions, don't hesitate to leave a comment below.